Alright, so we're looking at transformations today. Right, so that's where we take just a standard graph or even a point, and then we move it in some way, adjust it in some way. So the first thing we can do is translate, so translations. Alright, so don't forget we did these in units 1 and 2, so recall in units 1 and 2 that translations are when we move the graph, so it's moving the graph. Left, right, up or down. Alright, so another way of talking about these translations is what's called mapping. So translations can also be described in terms of a mapping rule. I'll get to what that is in just a moment. So if we're talking about, and you notice these symbols, symbols we've seen before, H and K. So a translation of H units in the X direction, and K units and K units in the Y direction. Can be described by the following rule. So if we start with some points X, a point X and Y, and then if we're going to translate H units in the X direction and K units in the Y direction, then the Y, X and the Y will change accordingly. So the way we write it is XY, and we put an arrow, and that arrow represents maps to, and it moves to X plus H and Y plus K. So plus H is your translation in your X direction, and the K is in the Y direction. So it's moved from here to here. Alright, so that's just another way of writing it called mapping. Now, if you like to think about it, this is our old here, and this here is our new. So another way that we can write that is that the new X represent the new x by x with a dash. So that's our new x. Would be equal to x plus h, where the x was the old x, and our new x value, we can also call that the image. And similar for the y, the new y, y dash, would equal the old y plus k. So there, the new y value and the image. All right, we did that as a point, but we can also, do it for a function. And so I'll do an example here of how we might do it for a function. So let's have a look. How we might do it for a function. E.g. find the equation of the curve fx equals 1 on x under translation of 3 in the positive x direction. And 2 in the negative y direction. All right. Okay, so if we use these representations of that mapping, so the new x value, you translate the old x value by whatever h is, and so when we look in this particular question, it's talking about translation of 3 in the positive x direction. So our new x would be equal to the old x plus 2. And for the y, it's talking about in the negative 2, in the negative y direction. So the new y is the old y minus 2. Now what we are doing here is we've got fx equals 1 on x. Now, I'm going to write fx, instead of writing fx, I'm going to write y, just for the purpose of doing the algebra of it. When we look at that, this equation's got y and x in it. So what we do is we come over to here and we have a look and say, okay, well these have got x and y in them as well. So if you rearrange this to get x by itself, then we could put that x in here, substitute it. So if I do that and I take, so x dashed minus 2 is equal to x, and so now I can take this x dash minus 2, so the new x minus 2, and put it in here. And similar for the y, if I add 2 to both sides, y dash plus 2 is y, and so I can take that y dash plus 2 and I can put it in here. Alright, so if I do that, I'll get y dash plus 2 equals 1 on x dash minus 2, 3, it should be 3, didn't pick me up, 3, terrible. So x dash minus 3. Alright, then take the 2, so you get y dash equals 1 on x dashed minus 3, take 2. And so what we can then say is that the image is, now that I've written it's the image, I can remove these dashes. So the image is f of x equals 1 on x take 3 minus 2. Alright, any questions about that mapping? Number 5. No? So that's our translation. So now we're going to look at dilation in a similar way. Right, dilation. Alright, so remember dilation stretching, and it depends whether it's from the y or from the x as to what changes. So from the x-axis, so if I'm stretching from the x-axis, so got something here, and I'm moving from the x-axis, I'm moving up that way, stretching up that way. Alright, so what's changing there is not the x value, but the y value is changing. Alright, so I'm going to say a dilation of factor, what are we using? B, I think, is that symbol, B, from the x-axis. And we're going to think about what changes. And as I've already illustrated over there, it's the y value that changes. And it changes by whatever that factor is. Alright, so the mapping is, we'd say, the x and y, the old ones, they get changed. What happens? Well, the x stays the same and the y gets bigger. So there's our mapping. Or in terms of the dashes, the new x and the old x are the same, that doesn't change, but the new y is b times whatever the old y was. Alright. And from the y-axis, again, again, we've got to have a look and see what actually changes from the y-axis. So if we've got this point here, we're moving from the y-axis, we're moving away from the y-axis. So it's the x value that changes this time. Alright, so if I look at a dilation of factor using this different symbol, factor A, from the y-axis, then our mapping notation, the old x and y, so the new one, well, it's the x value that changes by that factor, and the y stays the same. So in terms of ones with the dashes, the new x is a times the old x, and the new y is the same as the old y. Well, let's do an example. Alright, so I'll just do an example of the dilation from the x-axis. The process is the same. Determine for the image. And then y equals 1 on x squared. The x-axis. Alright, so using that dashed notation, so we know that if it's dilation factor 4 from the x-axis, the new x and the old x are exactly the same, they don't change. We're going from the x-axis, it's the y value because it gets stretched up, and so the new y value is 4 times what the old y value was. Now over here, I've got y equals 1 on x squared, and so that's the old y and the old x, so we need to replace them. So the only one, we don't need to worry about any rearranging of this one here, because the old x is already by itself, so we can just replace that by x dashed squared. The y, however, we do need to change that, and we do that by dividing by 4. And so now we can replace the old y by the expression that has the new y in it, which is y dashed on 4. And so then we can times both sides by 4. When we do that, you get y dashed equals 4 over x dashed squared. And so we now know that the image is y equals 4 on x squared. All right, the last bit's reflections. All right, to rub that off. Yep. Again, we've got to think about what changes with the reflections. So again, we could reflect in either the X or the Y. So let's look at in the X value, in the X axis. So we need to think about what happens. So if you've got something there, here it is, we're reflecting it in the X axis. So that means we're flipping it down to there. So what changes is that the Y from being positive changes to negative. So we could write that like this. In mapping form, the X and the Y gets changed. Well, the X stays the same, but the Y is now negative. All right, in terms of the ones with the dashes, the new X and the old X are the same, but the Y, the new Y, is the negative, what the old Y was. All right. Now, if we do it in the Y-axis, you need to think about in the Y-axis what happens. It goes from here across over to there. So it swings around that way. So what's changed there? Well, the Y hasn't changed, it's still up here. The X though has changed from being positive to negative. So the X and the Y get mapped to, well, the new X is negative of the old one, and the Y is the same. And the new Y and the old Y are the same. And an example. We right to rub that off? No, I'll just wait. Alright, so this one I'm going to do two parts. All right. So reflect it first of all in the x-axis. So just remembering that in the x-axis, it's reflected in the x-axis. The new x and the old x are the same. What changes is the y value. The y value becomes negative. So the new y is the negative of the old one. Now the equation we've got is y equals root x. Now that's the old y and the old x. So we've got to replace something with the old y and the old x by something from here. So no change here, because the new x and the old x are the same. However, here we've got a negative in front of the old y to get the new y. So what we need to do here is we divide by -1 both sides. We'll end up with that. The new y is negative y dashed, so we go negative y dashed in there. And then normally we don't like that there by like that, so we go y equals, y dashed is negative square root x dashed. So we're taking the negative square root. Alright, so the image, normally leave the dashes off, and so that's just y equals negative root x. Alright, so if we reflect in the y-axis, then the x changes, right, over here. So the new x is the negative of the old x, and the y's, the new and the old, are exactly the same. Alright, so if I change this around to get the old x by itself, over here I will have negative. Alright, and now I put that in. So y equals root x. So I'll put that in. The old y and the new y are the same, so the new y is equal to the square root of, replacing the old x by the expression with the new in it, negative x dashed. And so our image is y equals square root of negative x. And of course that means the domain's changed, of course. So negative x. So our original function, square root x, would go like that. And this reflected function goes like that. So this is the green is our original, and the blue is our image. So don't get confused here, the fact that we've got a negative under there, we're trying to take the square root of a negative number. Alright, what that does is change where the graph is. So negative x is here, negatives, and that negative, all good. Alright, any questions? No more questions. Alright, that's it. So 3A, B and C.